All right, good morning. This is the second lesson for 22.2 for my Honors Integrated 1 class. So again, I hope everyone's doing okay. Thursday's still in here with me. She's laying on the floor like a good old dog. And I hope everyone's doing all right out there. I think I already said that. But anyways, I wanted to have this in two different videos because I think it just simplifies things. So anyways, I'm going to get through the goals here pretty quick, and we'll see that this is actually a very simple lesson. Our first goal is going to be to define equilateral triangles and equiangular triangles. And then our second goal is show how equilateral triangles make equiangular triangles using the previous lesson. And we're actually going to do the converse as well. We don't really have to do any proofs, I don't think, on this one, because it's what you would call mathematics, just like an extension. We're applying what we just did. So let's go ahead and hit our first goal. An equilateral triangle is a triangle where all the sides of the triangle are equal. Okay, and an equiangular triangle is where all the angles of a triangle are also equal. Now, how do I say this? Every equiangular triangle is isosceles, but not every isosceles triangle is equiangular. Remember, the definition of isosceles is at least two congruent sides. So equiangular triangles are technically isosceles, but not every isosceles triangle is equilateral. And since this is an isosceles triangle, we get to use what we figured out about isosceles triangles. So before I go any further, what I'd like to do is I'd like to mark this triangle, which I actually built using a compass and ruler. I don't know if you remember doing that in the class, but I actually built this to be an isosceles triangle, and an equilateral triangle, and I'm going to put the marks on this thing, right? And the reason why I want to put the marks on this is I want this to look as similar to this isosceles triangle as possible, because we saw in the previous lesson that if I have an isosceles triangle that looks like this, then I know that the angles that are actually on the opposite side of the identical sides, they themselves must be equal. And so let's just say that we start with an equiangular triangle. If I cover this side up, I have exactly this. And if I have exactly this, I get to write that. So if I ignore this guy, I know that I'm going to have this happening. Okay? Now, for argument's sake, let's say that I cover this one up. I have this. It's just rotated, which means that this angle and this angle must be the same. You're going Thursday. So you would actually have to make a little argument here that, because this angle is the same as this angle, and this angle is also the same as this angle, then these two angles themselves must also be the same. So we just showed that equilateral triangles make equiangular triangles. It's pretty easy to do. Again, it's just using this. We covered up one of the sides we knew. And I can very simply do the same thing going the other way. So if I start off with a triangle, let's say has two congruent angles. Ooh, Thursday. Thursday's blind and she runs into things now. But let's sit down. Let's have a seat, bud. If I cover this up, so it looks exactly like this, that means this turns into this. Okay. And if I ignore this, that means that I have this, but it was just rotated. Which means now, let's say I covered this one up, which means this is the same as this. Right? And so I know that this side is the same as this side, as well as this side is the same as that side. And since these two are the same as this, then that means that these two must be the same. So again, we're just using the idea that we created in the previous lesson. Something else I want to talk about, equiangular triangles. We saw earlier that the three angles add up to 180 degrees. And if the three angles add to 180 degrees and all angles are the same, that must mean each angle, let's see, 180 divided by 3, that's going to be 60. So each angle is 60 degrees. I'm waiting for Thursday to knock over this. So anyways, this finishes our second lesson. So let me just write that down. Each angle equals to 60 degrees. All right. So that finishes this lesson. I think Thursday is ready to leave, and I better let her out before she runs into something and knocks it over. I hope everyone's doing all right out there. And again, let's make sure we keep doing all the assignments and turning in everything that we need to. Have a good day, everybody.